Okay, so during our lab exercise today, we started working on our little bike, and I wanted to show you a couple ideas real fast that will help us kind of understand the thought process, the sequence. Now, one of the things that you probably had an interesting time trying to describe was actually the wheel, right? Yeah, kind of difficult. How did you guys accomplish the wheel? What basic simple shape is it? A cylinder, right? So that's a good place to begin. But is it truly a cylindrical object? Well, a little bit. It's definitely cylindrical in shape. We can start with the cylinder tool here to help us very quickly describe the wheel. But let me show you some ideas. Now, I'm going to start with a 12-sided cylinder, and let's just do it real fast. Whoop. Excuse me. I left-clicked and dragged. There we go. And yeah, that's probably pretty good. Pretty happy with that. Rock and roll. Okay. So let's just look at this from the front again. Now, this is where the challenge and the interesting bit about working with the wheel comes in. How big is it, right? What's its overall shape? What are the dimensions of this wheel? Well, let's describe it real fast. And I think I'm just going to use the simple extrusion tool to help me get a really good, solid understanding of the size of this shape. So how big is it? I don't know. This is where my little brain's got to start doing some real modeling here. Okay. Somewhere maybe right around there. Wheel tires, especially on a road bike, are not astronomically big, right? So there it is. Let's center it along the z-axis just to make sure it's right smack dab there in the origin. Because if we're centered around the origin of the scene, believe it or not, we get a tremendous amount of choices in front of us, okay? Let's look at the front of our object again and return with our backdrop item on, and we can start doing some additional modeling. Because there's some really great details in here that we can and should easily create, right? Specifically, what I'm looking at and what I'm talking about are all of these wonderful little bevel profiles in here, right? Because it actually stair steps down. There's the tire, which is the rubber part, right? Then there's the actual wheel itself, which is the metal frame that the tire sits on top of. We've done an excellent job already on the outside establishing the tire. Now it's time to go in and start establishing the wheel, the rim itself. So let's do it real fast. Luckily for us, it's pretty easy. And this is one of the advantages of working at the origin, because I can actually do both sides of my tire at the exact same time if I select both. Okay? And with both sides selected, I'm just going to fire off good old bevel. Bevel's my friend, right? So now I can start beveling it in. Oops, excuse me. And I think I'm going to go a little bit further with a little too far, my inset values. Yeah, somewhere right around in there. Maybe I missed it a little bit, right there or so. Cool. And now we got to start doing that stair step down. So I'm going to hold down the shift key and click. And we'll give it a little bit of an inset, a little bit of a shift, excuse me. There we go. Shift, click. Do the red handle, and now I'm dragging out what will be the first part of the tire, and I'm pretty close, somewhere right around there. Yeah, pretty good. Now I got to do it one more time. Shift, click. Do a shift to bring it in. Yeah, it's a very narrow kind of change in form in here, but we can start to establish that pretty quickly. Okay, so there it is. There's the base of my tire already kind of fleshed out. This is the rubber part, and then all of this jazz in here is ultimately going to determine what the inside of the wheel looks like, the actual tire itself. Okay, excuse me, the actual wheel itself. Now, here's kind of a great trick. Last week, we spent a lot of time working with the bridge tool, and it's a power tool. We use it all the time. It's a good one to have in our back pocket, right? Up until now, how have we, or what have we been using as the selection kind of driver for the bridge tool? What have we been selecting? Edges, right? And edges are a great way to work with the bridge tool, but we can actually use a polygonal selection as well with the bridge tool, okay? So check it out. I still got the front, and let me grab the back of my wheel. And if I bridge them, boop, it's going to do not a single thing, because remove polygons was not on. There we go. There it is, rock and roll. See how it automatically removes those polygons and then bridges the gap for me, which is pretty great. Now that's a good looking wheel. Let me subdivide this for a second. We can take a look at it. Yeah, I'm getting there. That's starting to look pretty decent. However, the shape of the tire is really kind of off. I don't want to exclusively rely upon the subdivision surface algorithm to create that top curvature, right? So if I hit the tab key, look at it from the right, yeah, we're getting a pretty nice radius in here. This is great. I love this radius, okay? But it's being entirely, no pun intended, by the way, entirely created by the sub-D algorithm. We don't want to do that, right? We don't want to have the algorithm completely deforming our mesh outside of our control, right? We want to be able to put some additional control edges in there to help us create this lovely arc at the top, okay? So let's go back in time a couple steps, and believe it or not, I'm just going to use good old edge bevel to start defining what that shape's going to look like, okay? Let's increase the round level a couple here. Something like that. Now if we subdivide it, yeah, that's looking pretty good. We're still getting a very similar arc, okay? But at least we're controlling it now. It still looks like a tire unsubdivided. I think one of the errors that I see all modelers, not just beginning modelers like you, is that they don't try to describe the with polygons, with true polygons, right? We shouldn't be relying exclusively on the sub-D algorithm to create the shape. Our polygon should be doing that. The sub-D algorithm ultimately is just going to smooth everything out and make it look really, really pretty, okay? So that's starting to look pretty good. I'm pretty happy with that. How can I go in and sharpen some of these transitions? Because everything's kind of kind of melting together when I hit the tab key. How can I sharpen those transitions? Yeah. Let me subdivide it for a second here. Yeah, so then we'll just do a couple of them, like these down in here. If I run edge bevel again, and ensure that my edge shape is set to square. There we go. Now when I left click and drag, I can create some small little transition edge loops. We'll sharpen up those corners. Okay. Since I'm here and since it's so fast, let's just do it again. Yeah, and that's starting to look pretty good. I actually kind of like how it's rounding out the tire up in here, so I'm going to leave it as is. Yeah, looking pretty good. That's a good looking tire. That's a nice start for my model. I'm liking that. Okay. Let me turn on my wireframes once more. We can continue with our little job. Okay. So the rest of it from the front, if we turn it on, the rest of the stuff is just standard radial duplication, right? There's not a whole lot going on. But I wanted to spend a second here talking about maybe some strategies on something a little bit more complex. Let's turn off our backdrop item, and I started working on it while you guys were running your lab, okay? This is an interesting challenge for us. What we're trying to describe here is maybe the front downward, what's called a yoke, I think, on the front, okay? If you look at your reference, you can kind of get a good idea of what we're talking about here. So if you look at this section of the mesh, this in here, how does it look? What's its overall shape? It's a good question, right? It's a good question. If you look very carefully right in here, the reference starts to suggest it. If you look at additional reference out there, you can very quickly see that this is not just a straight cylinder that's got a slight bend to it, right? This actually wraps around the front of the tire. So, oops. If we take a step back, turn on that other mesh item, really, now I'm looking at it from the front. Really, this is the shape that we're trying to create here, right? It's because I'm going to have my tire in here, right? That's where my tire is going to go. And then this section in here needs to go down, and then it's going to go off like that, kind of making like an upside down U shape, right? This is kind of the shape that we're after. Whoop. Like that, okay? How can we create this? How can we get those really nice bends and curves in there to ensure that we're getting exactly what we're after? Say again? The tube tool is interesting, right? But it's not going to give you a tremendous amount of accuracy. Let's do it a little bit more accurate, right? Because accuracy kind of breeds control, right? We're control freaks as 3D modelers, or we need to be control freaks as much as we can as 3D modelers. I've started to flush out what the overall transition is going to look like, okay? And you heard me say during our lab time today to paint with a broad brush stroke. Define the overall shape as quickly as you can, as simply as you can, and I've done that for that transition, or for this downspout area for my bike itself. So here's that down tube. So in every sense, I've made it a little taller than it needs to be, but in every sense, the handlebars are going to be up here, okay? And then all that stuff floats down this way, and then into the tires themselves, okay? But how does this U-shaped pattern look down here? Well, I've started to define the angles a little bit. This is just a tube, and let me just show you exactly what I've done here so everyone is kind of on the same page. I started with that simple tube, and I copied it. Edit, copy, edit, paste. Oops, I copied it twice. There we go. All right. Now, let's start figuring out where that tube's going to go. Okay, let's just pretend it's right around in there. And I need one more of them. So I'm going to copy it, paste. This time, I want to be a little bit more precise with where and how I rotate this one. Last week we talked a little bit about the snapping engine inside of Modo, and we started to introduce the concept of vertex snapping. And vertex snapping is your friend. We don't always have to model around the origin, and vertex snapping gives us a tremendous amount of accuracy locally at the area that we're trying to work at, okay? Does anyone remember how to turn on our snapping engine? Anyone? Anyone? Where do we find the snapping toggle? You got it. At the very tippy top of our screen, and it's that button right there. It says snapping. Now, this is the global engine. It's literally going to affect every single moment of our modeling kind of session here in a second. Once we turn it on, it's going to influence everything. So let's enable it. We enable our snapping engine by clicking on the button or by hitting the X key. X as an X-ray on our keyboard, okay? If we hold down the Alt key and click on the button, we'll get some options. And I just like to make sure that vertex snapping's on. We'll come back to grid snapping here in a minute, but vertex snapping is where we want to hang out for the next operation. Because what I want to do is that I want to fire off the move tool. Now notice that as my cursor rolls over an existing vert, you can see that we're getting a selection, a little snap highlight. See that snap highlight? Now I want to put my tool handle right there, okay? And now I want to move this pipe up. Whoops, because I'm zoomed in, it went crazy. Let me hit undo. I want to move this pipe up until it snaps, boom, to its friend right there, okay? Which will give me some accuracy, because ultimately what I'm trying to do is that I want to rotate this little pipe around that corner. And I can do that quickly and with a high degree of accuracy using our vertex snapping system. Now, I'm not entirely sure what angle this is, and I really don't necessarily care what this angle is, but I'm just trying to rotate it around a door from that point, okay? You'll see why here in a minute. Okay, let's turn off our snapping engine. We don't need it for the next step. And I want to make this pipe a little bit smaller. By changing our action center to selection, the tool handle will automatically follow the slope, the angle of the selected piece of geometry, which is really neat, which allows me quickly and almost instantaneously to shorten it like that, whilst preserving the angle that I just created using that snap. Let's go back to none with our our action centers. And now I can start crafting the transition between that one and that one, okay? I don't know what that angle is. I don't care. I don't need to know. That's why I'm working in front of a computer, because the computer is going to fill in the blanks for me. It's a thinking machine. We're going to ask it to kind of flush out some of this information for us. Once again, we're going to return to our lovely friend Bridge. And Bridge is kind of cool. As I said last time, it's a power tool. This power tool is going to connect the dots for us. And I'm being a modeler. I want to make this a little bit shorter. What I'm trying to do is visualize a nice smooth transition between those two pieces. Check it out. If I grab that polygon and run the bridge tool, remove polygons is turned on, and now when we click, it connects the dots, okay, which is cool. But check this out, right? This is one of the things that I really like about the bridge tool. If we increase the segments here, Watch what happens to the transition between those two pieces. You can even left click and drag in the interface to interactively do that. See how it automatically tries to smooth it out? It's not a linear line, right? It's pretty cool, right? It's pretty cool. And now I know that I've preserved that is perfectly straight up in there, and down in here on this row of polygons, that's perfectly straight, and then everything in between was figured out for us, okay? Which is pretty nifty. I like that very much. All right, and then my wheel is going to go somewhere down in there. Now, one of the cool things about this entire process here is that I now have a tremendous amount of information that I can use to either cut up certain pieces of my geometry and make some good modeling decisions for me, right? For example, one of the things that I can do now, if I'd like, is maybe mirror that front tube, right? I don't have to make it, I need two of them. So let's change my action center to origin. I'll run the mirror tool along the x-axis, and now I have maybe a more representative idea of what this piece is going to look like. This in here, now we have some choices that we can make. I can live right there, and I can be a happy camper. Okay, let's do this. I want to hide that top piece. And I want to change my action center to selection on both of these. I should have done this before I did the mirror, but if you intersect them like that, there's a benefit. And let me show you what that is. A lot of you guys are weld them together. You really are. You could weld them together if you'd like, but let me show you something that's really neat here. Now I got some polys poking out the front, so here's my kung fu. I'm just going to do a loop slice here, somewhere right around in there. Do the same thing on that side. Okay. And then I'm going to grab these top polygons, and since my action center is still on selection, I'm just going to scale them down ever so slightly. And I mean ever so slightly. That way we don't see those polygons popping out the front. I mean, I'm doing not even a 10% change in scale. I'm just trying to get them all to hide inside. Same with this one. Just make it a little bit. Yeah, we'll keep that one as is. I won't worry about that leading edge for now. But here's where I was going with this. If we run over into our render layout, let's find this part. Okay. Now that little shadow there is something I gotta manage, but I'm intentionally not working with that right now. We have a great option here inside of our material properties that I use often. If we go into our material reference section, let's give it a fun color. Let's make this, I don't know, a red bicycle. Kind of an orangey red. There we go. Awesome. Check it out. It's this rounded edge width. This is a whole lot of fun because it's going to do some of the heavy lifting for us. If we increase this up, we probably, how big is this? I need to make it much bigger. Is it doing it? Yeah, it's doing it. Why is it not getting that transition there? It's doing the front, whoops. It's doing the front bit. Is it doing it in here too? It should be. Yeah, let's turn the roughness down quite a bit. Geometrically, that should have started to create and capture a little highlight for us right at that intersection line. Something else is at play here, which is causing it to not work. It should have rounded it out for us automatically. Actually, you can start to see it here in the back. Getting a nice little edge. Let's put it to 200 millimeters. Maybe my value, yeah, see, it's doing that one. Why isn't it doing that tube? Now I'm just like absolutely determined to figure this out. Yeah, it's doing it there. It's doing it, but why didn't it do it when it was pushed in like that? Yeah, it is doing it. Actually, I have larger problems at play here. right. Modo's choosing not to render my scene correctly. Well, small detail either way. Small detail that we can continue to fix and refine as we continue fleshing out the model itself. However, from here, how in the world did we create these handlebars? Interesting challenge, right? Very interesting challenge. I liked what some of you guys were doing in the sense that you were using like the tube tool and then crafting that curve by hand. Let me show you an alternative, which I really like. It's called the bend tool. You really see the product and the problem? Not too much, so I wouldn't focus on it. Far too often we get too close to our model. And we got to remember what the render engine is going to create for us. Okay. Questions on that? Handlebars, real fast. Handlebars. Okay. This is a fun one. How in the world, especially if you looked at the, let's start off with the cylinder. I'm going to create a new mesh here. And shoot, we'll just do it in here like this. Start it off. Okay. Let's get rid of that material too. There we go. All right. So the bend tool is pretty neat. I like working with the bend tool because it allows us to, well, for a lack of a better term, it allows us to bend things. The quality of the bends that we make is entirely, and I mean entirely dependent on, let me rotate this. I realized I had it going the wrong way. There we go. It's entirely dependent on how many edge segments are in the tube or in the object that we're trying to bend. So let me do this. I want to bevel this out. In every sense, I'm establishing the start of my bend with an edge. And then we also need to establish the end of our bend with an edge. Okay? So one more bevel. Okay, so this is where I want the bend to happen in there. Okay? The more edge loops I have in this area, the higher the quality of bend we're going to get. So let me just loop slice this, and I'll put in, oh, I don't know, 5 or so loops uniformly spaced. Okay? Now, let's fire off the bend tool. You can find the bend tool in your deform collections of tools, and there it is, right there. Here's the bend tool. Now, where we click inside the scene is important, because in every sense, it's going to determine the start of the bend. Okay? You're going to get this little blue circle. Now, pay attention to the orientation of this blue circle, because in every sense, this plane represents the angle and the direction that we're going to bend this shape. Okay? Think of it like a little plane that's bending this shape along that orientation. FYI, it's always going to work in conjunction with the work plane. Let me turn the visibility of my work plane on so you guys can see it. There it is. There's the small little work plane grid. The bend tool indicator is always going to fire and be placed on the work plane. So, and let me just show you kind of the product of that, right? So if I grab the little circle, you can see which direction and how we're bending it, right? If I drop the tool, change my work plane, or change my view so my work plane changes its orientation. Now, with the work plane cruising along the XY axis, the bend tool kind of axis plane is going to be flipped 90 degrees. And now I'm bending it like that, okay? So the orientation of that disc is really important. All right, I'm going to look at my scene from the top. Sometimes these bends are easiest done in an orthographic view. I want to be pretty specific. So with the bend tool, you're going to get some interface here. And these two pieces are really important. Of course, as we just mentioned, this over here is going to be a representation of the plane that you're bending these polygons along, right? But there's a couple other parts of our interface that are equally as important. Here in the center of that circle, we have an X, okay, or a cross. That cross represents the start of the bend, okay? That's where things are going to fire off initially. So in every sense, what's on the opposite side, what's on the right side of that cross is not going to be bent. Inversely, on the other side of this dotted line here, well, actually it's just a purple line, we got a line here, okay? We have a cube. this cube over here represents the end of the bend. So the cross represents the start, the cube represents the end of the bend. Okay? So I don't want my bend to end over here. I want it to stop right in here. And now when I run this, you can see that these polygons aren't getting deformed at all. And only between that edge loop and that edge loop are we bending the pipe. Okay? Now this is really great because now I can go in, whoops, that was fun, not bend it that much, but I can bend it like almost perfectly negative 90 degrees. Okay? Got a nice little elbow joint there now. And now I can continue modeling, right? Because I can grab that, I can bevel it out. Let's see, the next one's pretty big. There we go. So this in here is going to be the area that we bend. So I'm going to run loop slice. I'll leave the count to 5. The bend tool also works with selections, right? So if I only have those polygons selected, the ones that I want to edit, those are the ones the bend tool are going to influence. And once again, I'll fire it off. I'll bend it down. Cool, huh? Now we're starting to flush out what the handlebars look like. Okay. Now to get a more perfect curve in here, as an alternative, let me go back in time a couple steps. There we go. Let's do this. Let's take this edge loop, really move it down over here, and I want to put maybe 10 new edge loops in that area. And I want to bend this entire section in here now. Okay. So we'll run the bend tool once more. However, this time I want to bend it 180 degrees. Negative 180. And there it is. Aha. Coolio. Now the distances are close, right? The distances are really close, but we're pretty much where we want it to be. And there it is. That could be the underpinning of the handlebar pretty quickly. The bend tool is fantastic. We've been looking at some Roman columns, some Greek columns over the past couple weeks, right? We used them last week to demonstrate the duplication stuff. We did that Parthenon assignment at the beginning of the semester, right? If you look at a lot of Roman columns or Corinthian columns, I think they have those wonderful little leaves at the top, right? Have you seen those on the columns? They're wonderful, and they're bent quite perfectly, right? If you're making a 3D model of that, that'd be almost impossible to model on the column itself. What would be more possible, okay, and something that we can easily do is model that leaf flat, right? Because modeling things two-dimensionally on a flat plane is easy, and then when we're done, we can bend it to match the curve at the top of our column, right? So the bend tool is a pretty powerful tool. It allows us to very quickly deform these shapes to create something that would otherwise be very, very difficult to model, just using our simple block-out tools. Okay? Any questions on that? The bend tool is a pretty powerful addition to our modeling workflow. Okie dokie. Now, I wanted to spend some time today talking about architectural visualization. If you cruise over into D2L, you'll see that this week's homework assignment is a house. And let's just go over there real fast. Here we go. You guys are going to be making a house. This is going to be a 2-part assignment. This week, we're going to do the modeling, right? And then next week, we're going to focus all of our energy on creating a whole series of textures. Now, the texturing workflow for something like a house is very different from the texturing workflow that we've seen in other areas, right? And we're going to talk about how we can apply these textures in a way that gives us a great degree of control, but keeps the results very, very high. So the focus this week is just on the geometry. You're just building the geo, the house, okay? And then we'll talk about texturing it next time. So how do we get there? How are we going to be able to very quickly create a compelling structure, if you will, that suspends disbelief, but at the same time gives us a high degree of control over certain details like the windows and the doors, right? We want to be able to quickly get through this process, but still be able to control all the polygons in our scene. And there's some tools built into Modo that are purpose-built for architectural visualization. the 3D world, or excuse me, the architecture world is a perfect application for all of our 3D tools, right? It's very, very easy to see the benefits of making a model of a house digitally in the computer versus actually going and knocking down some walls and trying things, right? This is an exploding area out there in the real world. Architectural visualization is a defined industry unto itself, right? So if you're looking for opportunities here locally, look at architecture firms, okay? You can work with them to visualize their drawings and create some really stunning renders, okay? So let's go in and start looking at how we can start making some house geometry and what we can use inside of Modo to get us there very, very fast. All right. Okay, so I want to show you guys a really great way to very quickly create a floor plan, right? Because when you're defining a house, the elevations of your house, the floor plan is a great place to begin, right? And you guys have seen the floor plans of a house, right? It's kind of a top-down shot. You get to see all the walls, their thickness, the relationships between all the rooms and the doors, the windows, the bathrooms, et cetera, et cetera. Well, we want to be able to very quickly create that exact same floor plan with our tools inside of Modo, okay? Now, with the existing tool set that we have in our back pocket, how in the world will we do that right now? How could we create a floor plan quickly with just the tools that we've already talked about? Any ideas? Yeah, the cube tool is a good place to begin. But man, houses are very rarely perfectly square. Yeah, the basic shape tools and working well with the floor plan, okay? Luckily for us, we have a new tool that will help us get there pretty fast, and I like this tool. It's one of my favorite tools. Believe it or not, it's called the pen tool. And before you get really excited, the pen tool in Modo is very, and I mean very, very different than the pen tool over in like Illustrator or Photoshop, right? They share a common name, but their application and function is very, very, very different, okay? Let me show you what it looks like. We can find the pen tool inside of our basic collection of tools. Let me travel over there real fast. Here's the basic, and this is it. This is the pen tool, okay? Now, if you're really interested in looking at some of the other tools, check it out. There's some other tools in here that are fun. Here is the pen tool over in Photoshop and Illustrator. It's the Bezier curve tool. And we're going to talk about curves in the future. We actually have 3 different types of curves that we can make. I love working with curves. We have, this is called a Hermite curve, technically. We have B-splines now, which is really great. And of course, we have the Bezier curves, which you're used to seeing over in Photoshop. But our pen tool is going to allow us to very interactively draw some geometry. Let me just show you how it works. Okay, so the pen tool is always going to create its shapes on the work plane, and keep that in mind. The work plane is always going to be influencing literally every tool, right, including the pen tool. With the pen tool on, where we click is going to establish a vert on a feature polygon. 1 by itself is kind of meaningless. If we have 2, now we have an edge, and the moment that we click the 3rd time, now we have a triangle. And we can start adding and continuing these control surfaces anywhere we want to create an n-gon, a custom user-defined shape. And this is extraordinarily handy, right? Because now I'm in the driver's seat and defining the basic profile or the basic shape of many different things. Okay, I want to show you some UI here that are important. You're going to start to see this, and you have seen this in other areas of the Modo modeling tool set. Specifically, what I'm talking about are these little blue cubes, okay? These little blue cubes down here are the control points for the pen tool. Now, these are editable. While the tool is still on, I can go in and grab that little cube, move it around, change the shape. Life is good, okay? Notice that whenever I grab one, there's always, the one that I just grabbed is always going to be gold. There's always going to be a gold cube on your pen. That means the gold one is the active one or the current one, okay? Any changes that we make, any additions or subtractions that we make to our mesh are going to come immediately after the gold one. So if I wanted to add another point like way out over here, I can just click and it will add that point, right? So you can keep drawing your shapes as you go, but those new control points are almost always going to be created after the gold one. So if I wanted a new edge, for example, if I wanted to create a new control point in here, which of these two would I need to select? It's always going to be created after, right? So if I wanted to create a new control point, kind of where that cube is, I'd select the rightmost control vert, right? Think of it like we're going around, we're drawing our shapes in a clockwise manner. So if I grab that one, and now when I click in here, it creates the shape that I'm after. All right. All right, I like working with the pen tool. It gives us a tremendous amount of control, right? And in every sense, this is a great place to start drawing our house, okay? Because now we can create a custom shape quickly, right? Does this look like a floor plan, though? No, not really. It's a great tool to have in our back pocket. It allows us to define a floor plan pretty quickly. But I want to show you one extension. It's an option of the pen tool that cannot be missed. It's probably one of the most powerful features inside of Modo. Believe it or not, it's just called wall mode. Wall mode. I'm in the pen tool options now, and we're going to turn wall mode to inner. And this offset value is going to be something that's important, depending on how far you're zoomed out from the grid. And now when I click, check it out. Instead of making a user-defined kind of n-gon, what's it doing? It's making rectangles. It's making walls. Okay? It's making walls, which is very, very cool. Very cool, actually. Okay? And if you look carefully at each of the corners here, this is exactly how they should look. I'm pretty pleased with this. They've mitered the corners down here, which is nice. I like that very much. Okay? Yeah, that's pretty fantastic. Now, while the tool is still on, let's close our walls here. While the tool is still on, you can actually change the size of this in here. You can make your walls bigger. Okay? You can make them smaller. The wall mode will determine on which side of your vert each of your walls are going to be generated from. So on inner, this is the result that we get. If we do outer, you can see the walls are now drawn on the inside. Okay, the verts are on the outside. And both sides, I'm not sure why you'd want to do both sides, but it's there, right? That's a function that you have for you. Now, so that's pretty cool. Let me drop the tool here. And let's start working with some accuracy, because the one thing that the pen tool doesn't really allow us to do well is to go in and, last time I checked, most walls are kind of straight to each other, and often architects like to put like 90-degree corners in there and stuff, right? So having some control over how all of our walls are initially created is something that I'm attracted to. And luckily for us, the guys and gals down at the Foundry have given us that function in our snapping engine, right? So keep this in mind. The snapping engine is going to be a critical portion to this, okay? Let me show you what I'm talking about. I'm just going to drop the tool, delete what I have, and return to my snapping options. So this is the global snapping enabler, right? It's the toggle button. How do I get to my snapping options? The tooltip pop over there will help you. Yeah, so you can hold down the Alt key and then click on the button, or F11. So hold down the Alt key, click on the button. You'll get a cool little pop over. And then check it out, down here at the bottom, yeah, we got world access, straight line, yeah, and then right angle. That's what I'm talking about, man. Let's turn off Vertex Snapping just for the time being. And now with those three things enabled, check it out. The pen tool becomes very, very powerful, okay? Because now I can snap to some straight lines. Oh, I didn't even turn my snapping engine on. Let's try that again, huh? was like, why isn't it snapping this? There we go. Now it's doing the boop straight line snap. And then yeah, there's the 90-degree snap. Excuse me. Yes, awesome. I like that very much. Okay, I like that very much. So these tools will help us very, very quickly ensure that we have 90-degree corners in there, that planes are straight lines to each other. Awesome. Pretty cool, huh? Yeah, our snapping tools are pretty amazing. They allow us to work quickly and organically in the viewport, yet still get the accuracy that we need to get some pretty specific results. Okay, we're going to see this snapping engine in play here in a minute, and it's, you know, I can't live without it anymore. I really do, and I'm not saying this is not a hyperbole. I really do believe that it's the best snapping engine in the business. It really is quite good. All right, let's start generating something of interest here, okay? Of interest, because what I want to do is start really quickly kind of defining, you know, a small house. So let's make a floor plan, okay? Now I'm going to do this initially by looking at my scene from the top. Oops, that's the bottom. There we go. And of course, we're going to want to do this around the origin. And I'm simply, with my snap still on, I'm simply going to draw a fun house. I don't know what this is or what this is going to look like. Okay. Let's see. Let's make it somewhat interesting here. This is going to be my awesome deck, my little patio out over here. Got to have a patio, right? My house is going to be generally kind of boring. But maybe I'll have a nice kind of angled front doorway like that. Okay? So it's going to be kind of a bungalow. Okay? Well, how big is my little bungalow? That's supposed to be an entire house, right? How could I figure out the overall dimensions of this? When working inside of the architectural visualization world, scale, the dimensions of our objects, is actually something that we need to be kind of zeroed in on, right? Because if we can make a relationship to real-world scale units, it's going to be a whole lot easier, right? We can now use reference points that we see all over the place to help us model. Case in point, that door over there. How big is the door? We have a reference point over there that tells us how big of a door it is. It's probably 6'8". That's my guess, okay? Because most doors are 6'8", 30 inches wide, okay? We have building codes that actually determine the size of doors, the thickness of walls, how thick windows can be before they have to be like double paned and all that stuff. I mean, there's a lot of information out there. And if we're working inside of a scaled model system, it's going to be easier, right? Because we can use those numbers, we can use the data points and the information that we can find online to kind of fuel our modeling process. But let's visualize this a little bit. I still don't know how big this house is. Okay? Luckily for us, the folks down at the Foundry have given us a great, great tool. It's in the View pull-down menu at the top of the screen. And if you travel all the way down to the bottom, Dimensions tool. Okay? This is going to tell us how big things are. Aha. Awesome. And you can start to see it inside the viewport. Now, they're kind of small, but you can see it, right? You can see all the numbers. So right now, the total length of my house is 7.877 meters, and the width of my house is 7.372 meters, right? What in the world, right? Does anyone speak meters in here? I wish we would, right? I really wish we would do the metric system. I saw a really disturbing graph the other day of how many countries around the world use metric. And it's something like 98% of the world uses the metric system. And then like us and like one small country in Africa uses, you know, the standard imperial system, which is just the silliest thing on the face of the planet, right? Metric is so much easier, but it's not what we use in good old America, right? So let's get our unit of measurement into a system that we're used to seeing. Now for us, what are we used to seeing if we go down to Home Depot And look at all the dimensions of their lumber down there. Feet and inches, right? You go get a tape measure or a ruler, it's going to be in feet and inches, okay? Right now, the default system of measurement is in meters. It's in metric. And we can change this pretty easily. Check it out. If we go to the top left-hand corner of our screen, to the dark Modo pull-down menu, what we're going to see in the second one down here is preferences, okay? These are our global Modo preferences. And we actually have a preference area here. I got to find it. I'm horrible at consuming lists. It says, somewhere in here it says units. Is it under UI? Input, thank you. Yep. Input, there it is, units, right there. Okay, so the input category, units, and then it's going to be right up here at the top, right? We want it to be English. The default unit is feet, okay? And now, check it out. Haha, is it updated? Yay! Let's see if I get that bottom number in there for you guys too. Okay, so let's figure out how we can read this, because understanding how the computer's understanding how the computer's representing feet and inches is really, really important, okay? Because we can then use this in our modeling process as well. Okay, so here's the key. When it says, it looks like it's 24 feet, so 24 feet, okay? This is equal to feet. This, a quote, so an apostrophe is feet, a quote is what? Inches. You got it. Okay? Inches. Apostrophe equals feet, quotes equals inches. Okay? Write that down in your notes, because this is something that we're going to be using often going forward in the future, and it's good to have this kind of at our disposal. So I can just see pretty easily here that this is 25 feet, okay, and 10.12 inches. That's a pretty big house. That's not bad. I like that. That's actually pretty good. Yes, sir. So it's under the View pull-down menu at the top of the screen, and the Dimensions tool is almost at the bottom. All right, so 25 feet by 24 feet. That's a pretty big house. I'm happy with that, right? I'm really happy with that. But what I'm not happy with, and I'll just do this on a new mesh item, is that I'm not sure how big my walls were when I initially created them. And this is actually kind of neat. Let's run back over here into the pen tool. Okay, I got my wall mode turned on, and I want to enable Vertex Snapping, and I'm just going to snap a new series of walls to the existing verts to my underlying mesh, okay? And let's do inner, or outer, excuse me. Not both sides, that was a misclick. All right. So, and this is what I was going for. How big is an exterior wall? Does anyone know how big an exterior wall is? It's 6 inches. Yeah, it's 6 inches. That's how big, believe it or not, the only distance between us and that storm, over the weekend was 6 inches. That's the standard exterior wall size, right? So, if I put 6 inches in there, hit the enter key on my keyboard, now I know that all of my walls are 6 inches, okay? Because I can change this value. Let's do this. Yeah, let's do, 6 inches. There it is. Aha, wonderful. And if I wanted to grow my walls going the opposite direction, I could do that, which is what I was after. All right. Happy camper. Happy, happy, happy. Let's turn off my dimensions tool and start working with this shape. Now let's center it. And I always like to stay at the origin of the scene. Life is made easy if things are at the origin. Now we have the basic floor plan for our house done. Now what's next? Yeah, let's actually make it three-dimensional, right? So we got to give it some height. Well, how high are the walls of our house going to be? Yeah, 8 feet's a good place to begin. Some places have 10-foot ceilings. Like in my house, all my ceilings are 10 feet, which is kind of nice, okay? But these are things that we can measure pretty quickly. So let's do like 10-foot walls, okay? So check it out, okay? Let's extrude this shape up. Now I'm going to use the bevel tool because I don't want a polygon on the bottom. And check it out. Now you could just grab this number and go crazy with it, right? But pay attention. That shift value is actually feeding you a height value, right? I'm shifting those polygons up 6 foot 8 inches. How high do I want my ceilings? 10 feet. So let's just put 10 in there, okay? Now I know beyond any reasonable doubt that my walls are 10 feet tall. Drop the tool. Oops. Drop the tool. And life is good. Okay, so those are my 10-foot walls. Aha! Awesome. Pretty cool, huh? Pretty cool. Now that we have our walls, they're of the appropriate height, let's start going in and punching some windows in here, right? Now, windows are a little bit of a challenge for the most part because we physically need to create openings. Openings in our walls. How could we do that a number of times? I want to have, let's just prototype this real fast. Let's figure this out. I mentioned before that I wanted to have a cool little back patio out over here. So this is going to be my patio area. So maybe I need a window there. I want a whole bunch of windows along this wall. I want to be able to see basically at almost every single portion of my house here, right? So I want maybe a couple windows up here. This is where my front door is going to be, okay? This is the door. I want windows over here, windows over there. How can I create windows that are the exact same size along all the walls in my house? Interesting challenge, right? Now, whenever we're presented with an interesting challenge, let's think about what we're trying to get at. We're trying to create some holes in our walls that are exactly the same size. How can we do that? Loop slice is a great idea, right? Because the loop slice tool will allow us to very quickly define the top and the bottom edge of each window, right? That's the easy part. What's the hard part? Making sure that the vertical edges that represent the left and the right side of the windows are the exact same size on each opening, right? Challenge. Big challenge for us. We're trying to slice up our mesh. Not only are we trying to slice the outside of the walls, but we also need to slice the inside of the walls too, so we can create a hole, an opening, okay? What this is going to take us to is a really interesting tool set called Booleans, which will allow us to create geometry, right? And then use that geometry as a really fancy, like, slicer, if you will. This Boolean operation is going to allow us to cut geometry with geometry, okay? Now, I am in every sense opening Pandora's box, okay? With great power comes great responsibility. So you got to be careful with this because you could really destroy your meshes pretty quickly if you're not on it and if you're not paying attention to what you're doing, okay? However, when controlled, Booleans are a fantastic way of generating some pretty compelling information for us, okay? However, the first thing that we got to do is that we need to go in and define the size of our windows. So we got to create some geometry here, in true 3D geometry. So let's just do it real fast. I'll do it over here. How big do I want my window to be? Let's see. That's kind of the overall shape that I want. I want it to be kind of a tall, skinny rectangle. But how big is it? Well, check it out. Our tool properties are going to give us the size of our windows. This is one of the things that I absolutely love about Modo. It almost gives us like a CAD system, a computer-aided design system at every single tool. We're able to work with such high precision inside of Modo that we can do, we can make real-world dimensions instantly at creation, which is kind of nice, all right? So how big is my window going to be? How wide is it going to be? Oh, I don't know. Let's make it 3 feet wide. That's a good start. So it's going to be 3 feet by, 4 feet. That's probably a pretty good size window. Yeah, awesome. I like that. Let's extrude it out. Now, the length of this actually doesn't matter. Okay. Oops, I'm looking at my scene backwards. I was like, what is going on? Okay, there we go. So this is going to be the front window. Whoopsie. Now, when working with Booleans, this is important. We need to make sure that the Boolean, okay, the object that's going to be our geometric slicer, passes through the object that's going to be sliced on both sides. So if you look real carefully here, I've intersected it because I want this cube to slice that side of the wall and the front side of the wall, both the inside and the outside. Okay? So it's got to pass through. I probably made it a little too big, but we'll just do that. Okay, there we go. Now, where do we want this thing placed? What's a good natural height, you think, for a window? Low enough to climb through? Yeah, I think that's a good. So you could go in and measure this if you'd like, right? It's a 10-foot wall and a 4-foot high window, right? So that means we have like 3 feet on top and 3 feet on bottom that we can mess around with if we really wanted to center it. Most windows aren't truly centered on the wall vertically themselves, okay? They're a little bit justified up somewhere right around in here. That way, if you're standing at the window, a majority of the window is at an eye level, right? Because if it was centered on the wall, you can't dipping down a little bit, look through the window, right? So they're going to be justified more towards the ceiling than the ground. You could go in if you wanted to and really get accurate with that, but I think what I'm going to do is something fun like that. Okay? Okay, cool. So now, check this out. This is really cool, because we can just use our standard duplication system to make copies of this window. We've made one. Let's duplicate it. Let's just duplicate. I'm going to use the clone tool. And I don't want 13 of these. I think I just want to have, one. And I don't want it to be rotating 15 degrees. Somewhere maybe right around here. How many do I want? Let's see. Do I want 2 or do I want 3? Let's play around. Let's do 3. Yeah, that's cool. Okay, good. Like that very much. Okay. Now let's do the exact same thing. I'm going to copy that one. Edit copy. Edit paste. I'm going to rotate it 90 degrees. This will be the beginning of our next. I'm just going to make sure it goes all the way through the walls. That's the important bit. And I'll copy this one. We'll clone it again. And I'm using the between option to make sure I'm getting kind of a nice even spacing. There we go. Let's put one more in here. Whoop. There we go. Pretty cool. Don't have the. I'm going to copy this front one. Just copy, paste, move it back. It's going to be the back one. Maybe for this back one here, this is going to be looking out into my backyard. So maybe it's like one big massive one. It's like a big bay window. Okay, so I can absolutely do that. But you know, I've kind of made a mistake here. That's probably more like it. Okay, man, can you guys see that window is not in the center of that wall? I would really like it to be in the center of the wall. Left and right. Up and down, it needs to be offset. But left and right, I really, 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 really want it to be in the center of the wall. How can we do this? Any ideas? Now, I want precision. I don't want it to be close. I don't want to use my eyes, because when I'm modeling at 3 a.m., my eyes and my brain tends to get a little fuzzy. Okay? So I want the computer to help me out. Snapping, yes, because if you remember, our snapping system has a tremendous amount of control in there. Check it out. Let's go back to our snapping options. Now, I don't want to snap to the right angle world in a straight line. Maybe what I want to do is like edge center. Yeah, you feeling me? Because I want that shape to be in the center of that wall. which is basically the center of an edge. And it will snap. There it is. Boop. Now I know that that is in the center of that wall. Okay. All right, let's do it one more time. Copy, paste. I still got my snap on. There we go. And now I know that this shape is in the center of that wall. It's a little too big. I'm just going to scale it down. Maybe some custom windows. These are going to be expensive windows. The custom ones that are odd shapes are the ones that are crazy expensive, right? Let's just grab this one, copy, paste. Almost done with the layout of all my windows. And then I'll be a happy camper. Let's clone this one. Clone. Boop. Pretty awesome. Liking it, loving it. There it is. There it is. I have all the windows laid out. Okay. Now, in order for the Boolean to work, what we need to do is that we need to separate, and this is important. This is probably the most important part about working with Booleans. We need to separate the objects that are going to be the cutters, so in our case the windows, and the walls. Okay, they need to be on separate mesh items. Instead of going through and selecting a bazillion little windows, it's easier for me just to grab the walls and then to invert my selection by hitting the open braces key, which is the one that looks like this. Okay, so over by your P key. Okay, I'll invert the selection to get all the windows, and then I'm going to cut and paste them onto their own mesh item. So edit, cut. Don't worry, they're not deleted. Let's put them on their own mesh item by pasting them in, and there it is. Okay, now let's be good stewards of our scene here. I'm going to go back over to my item list and just rename this. Let's just call this house. Okay, and let's just call these cutters. There we go. All right, now for this next bit, we got to be real careful with what we have selected. We want to select the house geometry, so the object that's going to be cut. Everything that's going to be cutting, the windows in our case, need to be in the background of our scene, which means over in the item list, the visibility is still active. So the eyeball for our cutter mesh item is still on, but it's not selected. So in the background, unselected basically. Okay? If you look at the contents of our item list, I got my house mesh item selected. Its visibility icon is on. The cutter's mesh icon or mesh visibility is on, but it's unselected. All right, with that set up, we can go to the top of the screen to the geometry pull-down menu, and we're going way down here to the bottom where it says Boolean, and we're going to choose solid drill. Don't do it so we have 3 different Boolean subtools. Axis drill, solid drill, and Boolean. We want solid drill. Solid drill gives us the most options going forward, right? I'm a control freak. I want to be able to control what happens next, okay? Solid drill gives me a lot of choices in there. Let's look at some of its features. Let's turn on solid drill. You're going to get a little popover. Okay, this is what it looks like. Check out what the driver mesh is. This is any mesh object that's currently in the background or unselected. And then the operation, I like to do this. I'll let you explore all of them on your own time, but I like using stencil or slice. Slice is my favorite because it gives me the most choices as to what's going to happen next, right? Now, as soon as I hit OK, watch what happens to my walls. What happened? Did you guys see it? Yeah, if we turn off the visibility of my cutter mesh object, dun, da, 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 it sliced my geometry exactly where all those windows were sitting inside of our scene. Okay? That's pretty neat. Now, in the process of doing these Boolean operations, the computer's going to automatically go in and create these little slices here. It's just trying to resolve this surface because these are gigantic n-gons. So it's trying to terminate that surface at an existing vert, which is this corner one. Just leave them here for the time being. We can come back and remove them in a minute. Okay? All right. So now, how do we make the openings? Yeah.
Real quick,
Have your walls selected. You have it backwards. There it is. Yeah. So how can we create these openings? We want to create some holes in here. Here's the front of my house. Okay. Now you could go in and select them and then delete them. That's fine. Bye-bye. Okay. What do I need to do to these two edges? Bridge them. Yep. That works. Okay. That works. Let me show you a great alternative here. Go back in time, a couple steps. There's one thing that you could do is you can grab the outside polygon, the inside one, and then run bridge. Bloop. Saves you a couple extra clicks. Let's see, can we do it with multiples? That's a good question. If we turn on the bridge tool, before I click, let's do continuous bridge. Nah, it's going to bug it out. I had a hunch that was going to happen. What about auto connection? Yeah. So you kind of have to do them individually. I'm not going to do them all because I'm running out of time. But I'll just do those. Okay? Aha. Cool. So I do that going around the outside of my house. Now, what about the door? I want a door. I want a door, but is that a weird angle there, right? Is that a crazy weird angle? Let's figure out how we can create a piece of geometry that will match that angle. And I put that angle there intentionally because it gives us an opportunity to talk about some really great rotation tools. Now, doors they can be, pretty big. I want to have a statement door in my house. I want it to be, let's be 8 feet tall by 40 inches wide. Oops. $40 inches. At the end of the day, it's 40 inches there by 8 feet. There we go. Awesome. And I could have even extruded it there too. All right, so there's my door. It's going to be a big door, right? It's going to be a gigantic door. Let's make sure. I want to make sure that polygon down there at the bottom is perfectly at the center of the y-axis. Actually what we'll do, we'll leave it as is just for the time being. Okay? So here's my challenge, right? I got to take this door and rotate it to match the angle of the wall that it's going to be sitting on. How? How am I going to do that, right? I could eyeball it, but do you think I want to eyeball it? No, because if you're off, this is what's going to happen if you're off. If the angles don't match, check it out. It actually is important, okay? I want to put my door in with my other cutters and then just get rid of my windows. I don't need them anymore. So check it out. If I run the Boolean again with it being off, yeah, this opening here is now at an angle. Oops. Yeah, it's at an angle. Yeah, check it out. You can actually see the angle right there. That's not a perpendicular or 90-degree edge in there, okay? So we have to be exact. Let me go back in time. Hit undo a couple steps. Okay, so how in the world am I going to get that door to the correct angle to match that wall? Well, let me show you. There's a really great system in here. And this kind of speaks to the awesomeness of the Modo tool set. Okay? It's pretty fantastic. Check it out. Over in our basic tool tabs, we have this palette here called Snaps and Precision. And there's some good ones in here. Okay? Drag, Snap, Rigid is awesome. Okay? We'll talk about that here in a second. But I want you to look at Planar, Rotate, Snap, Axis. This is going to do exactly what I want us to do. And actually, let's do Drag, Snap, Rigid, because Drag, Snap, Rigid is going to allow us to, and hold on a sec, we're still doing Edge Center. There we go. Let's do Drag, Snap, Rigid again. Oops. Drag, Snap, Rigid. It's going to allow us to move things, boom, as a unit, right? And what I'm trying to do here is I want to get that cube and, oops, Looks like I made a boo-boo at some point. My walls aren't perfectly straight, but that's okay. I want to get the corner of my cube, right? So I want to use that angle here, this angle here, to help me figure out the rotation angle of that object down there. All right, so now that they're in position, drag, snap, planar rotate, snap axis is going to be our guy. And I've got to apologize. I'm going to drop my tool. I forgot to select my future door. Let's run it again. Now, where we click is going to represent the area that we're going to be rotating around. So this is like the hinge. And there's two really important interface elements inside of here. If you look carefully, we have this little, because I'm all zoomed in, it's going crazy. We have this little cross. Then we have this purple handle with a little widget on it, okay? That little cross is important. And we want to place that cross at what I would call the starting angle. So I want to place it on that corner right there. See how it snaps? Boom. We're establishing the start angle of our rotate operator. This next one is the purple. The purple guy actually rotates the object, and since I put that cross at the corner of my cube, I can place my purple cross, the rotate indicator, on a corner. It snaps to an existing edge, and it does the work for me. And now I know beyond any reasonable doubt that that wall or that guy is perfectly aligned to that wall. Let's do edge center once again. I'll move this. Let's change our action center to selection. There we go. Now, with edge center enabled, it's in the center of that wall. Here's a cool thing about our snapping tools is that we can get what we're after. So now I want to just globally move this up and down. There we go. Now I'm dialed. I'm ready to rock and roll. Okay. I historically do this when I'm working with doors. I just push them a little bit further down. Awesome. And I'll run the Boolean once again. Just on the doors this time. Boolean, solid drill, slice. Run bridge now, and everything's going to be quite perpendicular to each other, which is what we're after. Ah, groovy. Done. Happy camper. Windows and doors quickly and easily punched in using Booleans, right? Using Booleans. Now, what about that roof? That roof is going to be an interesting one. It's time to raise a roof up in here, right? Let's do this. We'll look at my house from the front, and I want to have a roof kind of going like this. Maybe a little too big. Something like that. It's a gigantic roof, so maybe not that big. Because if my walls are 10 feet, the roof line needs to be somewhere kind of like right around in here. Okay? How are we going to create that? Let's figure it out. It's not actually that bad. What basic simple shape is a roof? Yeah, it's a cube, right? And we can planarly define our roof with some simple rectangles. We're going to keep it real easy for our first roof. Roofs can get very, very complex quickly, but if we have the walls of our house completed first, check it out. It's actually not that bad, okay? So I'm going to do this initially on a new mesh item, and let's figure out the thickness of our roof. Now, how thick is our roof, okay? While I'm drawing the cube here, I'm thinking about its dimensions. How thick is it going to be? It's definitely not going to be 20 inches. That's almost 2 feet. Roofs are definitely not that thick, okay? Does anyone know how thick a roof actually is? It's only about that. There's only a couple layers of plywood there that define your roof, and then the roofing tiles themselves are quite small. So maybe it's only, 2 inches, 3 inches at max. Okay, there's not actually a whole lot there. Let's put 3 inches in there. It's a good start. Here, I'll make it a little bit bigger just for illustration purposes so you guys can see what's going on. Okay. All right, so here's what I'm going to do to make a roof. I want to make a real long rectangle, and I'm going to start rotating it. And I'm not really paying too much attention to all of this side. I'm just looking at the angle, and I'm looking at how big the pitch of the roof is, and I'm pretty happy with that. Now this overhang way out over here is way too much, right? Check out that. That's just way too much of an overhang for our roof, right? If I have my action center set to selection, I can fire off my move tool and I can move that edge up to start defining the overhang on my roof. And I like that. That's a good start. Okay? Now, this side over here, if you look at it, really what I want to focus on is the center line. This side over here is what my brain has been looking at. Okay? I don't care so much about all of this jazz because that's slop to me. I'm going to delete it. So I'm making one half of the roof first, and then I'm going to mirror it to on the other side of the x-axis. Okay? If I use my slicing tools paired with our maybe grid snap, I can get some pretty quick options. Let's just turn on grid snap and just run Shift-C, get my slice tool. Zoom. There we go. Awesome. Don't need that side anymore. Now I have one half of my roof. Let's run the mirror tool on the, oops. There we go. Oof. With my grid snapping still on, it gives me exactly what I'm after. And there it is. Okay. Pretty pleased with that. I like this very much. Let's get it into position now. And I'm simply going to extrude it back using our standard extrude tool. All right, let's get this in. Let's look at it with the house. It's looking pretty good. Happy with it. Now, what's my next big problem here? What's next for me to solve? I have the world's best air conditioning system going on right now, right? I got a gigantic opening between the top or the bottom of my roof and the top of my walls, right? I can't have it be open like that. I don't want birds in my house. That'd just be weird, right? So I got to get rid of all of this stuff. I got to fill that in. Check out this. You can use the power of the Boolean system to get the end result pretty quickly. Okay? All right, let's just do it real fast. I want to grab the top of my walls, and I want to move them past the top of my roof, like that. Okay? Now, don't worry about it. It's going to look funky for a second, but we're going to use Booleans to get us where we need to go, right? This is my roof. Let's just name it roof. There we go. If I select my house, I can see my roof in the background. I'm going to run Boolean, solid drill, slice operation, yoink, and it cuts the top of my walls, which is what I'm after. And it perfectly now matches the pitch of my roof. Okay? Now I can grab that top loop, and while holding down the shift and up arrow, expand the selection down a couple and delete the slop. Go grab my roof. I'm going to cut and paste it from one layer into another. There it is. Perfect roof and perfect walls that all match each other. That's pretty neat. All with Booleans, right? Booleans are pretty neat. It's an incredibly powerful system. And if we pair it with our snapping engine, we get a high degree of control. Thinking of snapping, let's talk about the trim real fast on each one of these windows, okay? So I want to have some really compelling piece of trim that wraps around the window, right? In actuality, when you're making a window, this is what they do. They actually make walls with just big openings in them, and then they go put a window in, and then they cover the rough edge of the windows with trim. That's the function of trim, right? Let's make the window. Let's follow that process. Let's follow the exact same process that a construction worker would follow or would use to create their windows, right? So let me show you a great little trick here. Okie dokie. So here's what we need to do. I want to focus my energy on this one. Okay. What if I grab that loop in there and I start beveling it a little bit? Okay. Bevel it in. I'm even going to use real-world measurements here. I've just beveled it an inch. Okay, hold down. Let's do, that doesn't quite look enough to me. Let's do 2 inches here. 2 inches, that looks like it's too much. Let's split the difference, 1.5 inches. There we go. Hold down Shift, click. Then do a little bit of an offset here for an inch. Looks pretty good. There's the frame of the window. Okay. Shift, click. We'll do it one more time. This time we'll do a 1/2 inch. Shift, click. There we go. Now we have an opportunity to do like the glazing, the actual window itself. And here's an old school trick. So this is like the frame of the window. This is what actually holds the window in place, because windows are actually kind of sandwiched by 2 wooden frames on either side. They're pretty simple pieces of construction, right? This is going to create the illusion of that sandwiching piece. And here's a great trick. If you select those 2 polygons and run loop slice with a count of 1 and a spacing of uniform, you'll get an edge just right smack dab in the center of that window. And then we can just hit the P key to fill that selection with a polygon. And now we have a pretty compelling window that we created pretty quickly, too. All right, so there's one window, but now we need to make the trim that goes around the outside of the window. That's pretty easy, especially when we pair our snapping engine into the mix. And here, let me show you something. I want to use some Vertex Snapping. And what I'm after here is that I need to have a board going that way, and then another board going this way, and then another board going this way to create the exterior trim. And then we have the window sill down here, right? Well, I can do all of this, almost all of this, quickly, and in a way that gives me a repeating pattern. Let me just show you. I'll do one, and I'll let you guys do the rest on your own. I'm going to use the wall. I'm going to use the pen tool, in all honesty, because the wall mode paired with some snapping gives me some really neat choices here. So I'm just going to click on the corners. See where I'm going at? Okay. Of course, the offset value here is going to determine the width of my trim. I want it to be 2 inches. Aha, that's pretty cool. Let's drop the tool, and let's, you know what happened here. It actually merged. I had merge on. That's my fault. It actually merged the vertices, which I didn't want to do. There we go. I hid the rest, and oops, looks like I snapped it to the wrong corner. Me being the control freak that I am, I have to get that right. Go. There we go. And now I can simply bevel it out an inch. There it is. There's the trim for your window. Easily created and ready to rock and roll. Okay. Now I'm running out of time, but I would literally follow that exact same process going around the entire house. Okay. Now, when you're modeling your house this week, ultimately, at the end of the day, you're just going to be doing the outside. Just the outside. Don't model the inside. If I see any pieces of furniture on the inside of your house, I'm going to be a grumpy Pat. Okay? Just the outside. The inside is a whole other ball of wax. Okay? Just the outside. Okay? Let's go back over to the assignment sheet real fast and just kind of cover what the expectations are. Okay? So you're going to be making a house. The entirety of a house. Use the examples of the student projects to give you a good barometer as to how far you should be going on this. This top one's a really, really great example of where we're going. Make it your house. It can literally be any house that you want, but make it something that you know. Make it your house. You see your house every day, or your apartment complex, whatever. You see it every day, build that. That way you have a point of reference, something that you have a relationship with that you can easily build and understand all the little bits and pieces of. Okay? In addition, you're also going to be creating the landscape for your house. Don't go crazy, okay? But think about sidewalks, driveways, things like that. Your yard, a fence if possible. Again, use the samples that I provided you to kind of shoot you in the right direction. And then make some trees and bushes. Well, don't actually make them, but please, please, please use the presets that come with Modo, okay? So I've gone over into the Layout tab, and in the Meshes tab here, we have access to a whole bunch of really wonderful mesh presets that come with Modo, and I believe it's under the Organic section. Yeah, here we go. We have plants. Okay, use some of these. We have some trees. Use some of these. These are good places to begin, okay? Just put some trees down there. Put some shrubs, some bushes. Just start populating your yard and your landscape with something that's more than just a flat plane, okay? Those simple little additions go a long, long way to making your home feel a little bit more real. It'll be, kind of a little bit more human-centric, okay? And also remember, we're just doing the model this week. So don't go like full tilt and do all the textures, because the texturing pipeline that we're going to be talking about next week is very, very different than what we've talked about before. Okay? So just the model, please. Just the model. Okay? Questions? Everyone generally kind of understanding? Okay. All good projects begin with reference. Your homework this week, your lab, in addition to your homework this week, is to do some reference collection, okay? I'm forcing you to do this. You have no choice. You have to go out and find some reference images, okay? We want to build all models as if they're founded in reality. A house is no exception to that. That's a great question. Take pictures of your own house, okay? That's fine. You're not going to be expected to build the actual reference images themselves, okay? They're a starting point. They're the beginning of the conversation. Now, if you find reference images or if you take pictures of your own house, then build that house. It really makes it a whole lot easier to figure out how all these things go together. But be inspired. Use the reference images as a guide, a blueprint, if you will, for the actual object itself. You have to find, how many am I asking for here? I think 10, okay? Find 10, okay? Put them all in a zipped archive and throw them into the Dropbox, okay? I'm forcing you to do this. You have to look at some reference images before you can start building the house, okay? Everyone thinks they know what a house looks like until we build a 3D model of it. Then, if we're not using the correct reference and some good images to guide our decision-making process, things are going to go poorly, as they say, okay? All right, questions on this week's homework and lab assignment. Everyone kind of digging it? The reference should take you about 20 or 30 minutes. So it should be just knock that one out real fast and so you can get to modeling, as they say. Sound good? All right, I'll see you guys next week. May the force be with you. Hold on 2 seconds. Stop the live stream.